All right, good evening. We're going to look at solving the quadratic equation using the zero product property. Now, let's think about what those words mean. Zero product property. Product is the result we get when we multiply two things. And what we're saying is when we multiply two terms, they come to zero, which means that one of them had to be zero. It would be like me saying 0 times 4 is 0. So if I do 6 times 0, that's 0. So some number times 0 always gives me 0. We just have to find out what those numbers are. So here we've got our first question. It says solve for m. So we're going to set both equations equal to 0, or both expressions equal to 0. And then we're going to solve. So m plus 1 equals 0. I need to eliminate this positive 1. I do that by subtracting 1 from both sides of the equation. Therefore, m is equal to negative 1. Here, m plus 5 is equal to 0. I'm going to eliminate positive 5 by subtracting 5 from both sides of the equation. Therefore, m is equal to negative 5. So what I'm saying here is if I put in negative 1 and for m plus 1, that gives me 0, and 0 times this term gives me 0. On the other hand, if I put in negative 5 here and I add to it 5, that gives me 0, so 0 times this term would also give me 0. So we're just wanting to know what makes each one of these binomials 0. So I'm going to put in negative 1 and negative 5. Number 2, we're asked to solve for d. And we've got d minus 6 multiplied by d minus 5. When we multiply them together, we get 0. So again, we're going to do d minus 6 equals 0 and d minus 5 equals 0. Well, to eliminate this negative 6, I have to add 6 to both sides of the equation. Therefore, d is equal to 6. For the other binomial, I have a negative 5, and to eliminate negative 5, I have to add 5 to both sides of the equation. So d is also 5. So I just type that in, 6 and 5. I'm going to go ahead and focus this a little. Number 3, we are asked to solve for k. And we've got k minus 5 times k minus 4. And notice, guys, also that these are in factored form, right? So k minus 5 is equal to 0. K minus 4 is equal to 0. And so to eliminate negative 5, I'm going to add 5 to both sides of the equation, and k is equal to 5. And here I'm going to add 4 to both sides of the equation, so k is equal to 4. Now, you might be asking yourself, why do we have to solve for these anyway? Keep in mind that if we were to multiply these would come out to a quadratic. And that quadratic is crossing the x-axis at two different points. And those points in this case are 5 and 4. But if I were to write this as an ordered pair, knowing that I'm talking about the x-axis, I would write this as 5, comma, 0 as that ordered pair. That's one solution. And 4, comma, 0 as the other solution. So we're just not sitting here solving for the sake of solving. What we're saying is we want to know, where does this quadratic cross the x-axis? And these are the points that it does. So we've got 5 and 4. Okay, so let's move on. We've got number 4. We've got z times z minus 5 is equal to 0. This doesn't change our process. We're just going to put z equal to 0 And then z minus 5 equals 0. Well, this one we don't have to solve. We already know it's 0. Here, we add 5 to both sides of the equation to eliminate this negative 5. So z would be 5. Let's go ahead and look at number 5 up here. We've got 3h plus 7 times 3h plus 4 equals 0. And we're asked to solve for h. So we're going to do the same thing we've been doing. So 3h plus 7 is equal to 0. And then we've got 3h plus 4 is equal to 0. We're going to solve the same way we've been solving. So here, I'm going to eliminate the positive 7 by subtracting 7 from both sides of the equation. And I've got 3h is equal to negative 7. Well, I'm not wanting to know what 3h is. What I want to know is what is h. So, if I've got 3 multiplied by h, the opposite of that would be to divide by the number that's in front of the variable on both sides of the equation. So therefore, h is equal to negative 7/3. And over here, we're going to do exactly the same thing. We're going to eliminate the 4 by subtracting 4 from both sides of the equation. And I've got 3h is equal to negative 4. We don't want 3h, we just want h. So we're going to divide by 3 on both sides of the equations, and that leaves me with h is equal to negative 4/3. And notice it says write your answers as integers. We've done that. Or as proper or improper fractions in simplest form. So you need to make sure that you cannot reduce these fractions anymore, which we can't. So we've got 7/3. Oh, almost forgot that negative. And here we've got negative 4/3. Let's look at number 6. We've got 5c minus 2 multiplied by 5c minus 1 equals 0. Set them both equal to 0 and solve. So to eliminate negative 2, we're going to add 2 to both sides of the equation. We've got 5c is equal to 2. We don't want 5c, we just want 5. So we're going to divide by the number in front of the c, which happens to be 5. And we're going to do that on both sides of the equation. So c is equal to 2/5. We're going to do the same thing over here. To eliminate the negative 1, we're going to add 1 to both sides of the equation. And we've got 5c is equal to 1. Divide by 5 on both sides of the equation. c therefore is equal to 1/5. Let's look at number 7. We've got n plus 7 multiplied by 2n minus 5 equals 0. Process is the same. Take the first binomial, set it equal to 0. Take the second binomial, set it equal to 0, and solve. So to eliminate positive 7, we're going to subtract 7 from both sides of the equation. N is equal to negative 7. Here, to eliminate negative 5, we're going to add 5 to both sides of the equation. So 2n is equal to 5. Divide by 2 on both sides of the equation. N is equal to 5 halves. So we've got negative 7 and we've got 5 halves. Let's go ahead and look at number 8. So number 8, we've got x minus 8 multiplied by x plus 2 equals 0. So we're going to set both binomials equal to 0 and solve for x. To eliminate negative 8, we're just going to add 8 to both sides of the equation. Therefore, x is equal to 8. Over here, to eliminate positive 2, we're going to subtract 2 from both sides of the equation. Therefore, x is equal to negative 2. Number 9, we've got m plus 4 multiplied by 5m minus 2, and that equals 0. We're solving for m. So take your first binomial, set it equal to 0. Take your second binomial, set it equal to 0, solve for m. So to eliminate positive 4, we're subtracting 4 from both sides of the equation. M is equal to negative 4. Here, to solve for m, first we have to eliminate the negative 2. So we're going to add 2 to both sides of the equation. 5m is equal to 2. Divide by 5 on both sides of the equation. M is equal to 2/5. So m would be 4, and m would also be 2/5. Oh, I forgot to type in the negative. It happens. Oh well, let's move on. Number 10, and perhaps you saw that. You should have warned me. So we've got u multiplied by 3u plus 1 equals 0. Set u equal to 0 and 3u plus 1 equals 0. U equals 0, that's already solved for u. Now let's, oh that's funny, that's already solved for u. Now, here I need to eliminate the positive 1, so I'm going to subtract 1 from both sides of the equation. That leaves me with 3u is equal to negative 1. Divide by 3 on both sides. U is therefore equal to negative 1/3. This time I'm going to be more careful and put the negative as I should have the first time. So we were at 10. Let's go on to number 11. I'm lifting up my book here, and that's what you see going on. Number 11 says v minus 5 multiplied by 7v plus 2 equals 0. Set both binomials equal to 0 and solve. So to eliminate negative 5, I'm going to add 5 to both sides of the equation. Therefore, v is equal to 5. Here, I need to eliminate the positive 2, so I'm going to subtract 2 from both sides of the equation. 7v is equal to negative 2. We don't want 7v, we want v, so we're going to divide by 7 on both sides of the equation. And v is equal to negative 2/7. So I've got 5 and negative 2/7. Now we're going to solve for j. For number 12, I've got j minus 3 multiplied by 8j minus 5, that equals 0. Set each binomial equal to 0 and solve for j. So to eliminate negative 3, I'm going to add 3 to both sides of the equation. Therefore, j equals 3. Here, to eliminate the negative 5, I'm going to add 5 to both sides of the equation. And I've got 8j is equal to 5. Divide by 8 on both sides of the equation because I want j alone. And j is equal to 5/8. So we've got 3 and 5/8. Number 13. We've got r plus 4 multiplied by r minus 5. That equals 0. Set r plus 4 equal to 0 and r minus 5 equal to 0 and solve. To eliminate positive 4, I'm going to subtract 4 from both sides of the equation. R therefore is negative 4. Here, r minus 5 equals 0. I'm going to eliminate negative 5 from this side of the equation. So I do that by adding 5 to both sides. Therefore, r is equal to 5. So we've got negative 4. And r is also equal to positive 5. Number 14, we've got 8j plus 9 multiplied by 3j plus 1 equals 0. Set both equations equal to 0. To solve 8j plus 9 equals 0, we're going to eliminate the positive 9 by subtracting 9 from both sides of the equation. Got 8j equals negative 9. Divide by 8 on both sides of the equation because this j is equal to negative 9/8. Over here we've got 3j plus 1. I'll put a line between them. 3j plus 1 equals 0. Eliminate the positive 1 by subtracting 1 from both sides of the equation. 3j is equal to negative 1. Divide by 3 on both sides of the equation. J is equal to negative 1/3. So we've got negative 9/8 and negative 1/3. Number 15. We've got y minus 1 multiplied by y plus 4. And both of those are equal to 0. So again, take the first binomial, set it equal to 0. Take the second binomial, set it equal to 0, and solve. So to eliminate negative 1, I'm going to add 1 to both sides of the equation, and y is equal to positive 1. To eliminate positive 4, I'm going to subtract 4 from both sides of the equation, so y is equal to negative 4. So y is equal to 1 and negative 4. I think we'll do one last one. You could easily take this to 100, but again, time is of the essence. So I'm going to do number 16 here. 7m minus 9. And we're going to multiply that by m minus 5. When they're multiplied together, they equal 0. So again, we've got 7m minus 9. We're going to set that equal 0. And then we're going to set m minus 5 equal to 0. To solve the left-hand side here, 7m minus 9 equals 0. We're going to eliminate the negative 9 by adding 9 to both sides of the equation. We've got 7m equals 9. Divide by 7 on both sides of the equation. M is equal to 9/7. M minus 5 equals 0. To eliminate negative 5, we add 5 to both sides of the equation. M, therefore, is 5. So our answer to this would be 9/7 and positive 5. All right, we made it past 80. You go ahead and take it to 100. Talk to you later.